probably don't need my introduction. As a doctoral student at ETH Zurich, Gnanli worked with Professor Guillaume Haber, and together they have developed a process to turn clay-based excavation material into an alternative cement-free concrete. And I was lucky enough to be listening to the radio one night, and I heard this very interesting guy being interviewed about this material, and I thought, well, God, I've got to get in touch with him. So I had a fantastic conversation with you over the summer, and you agreed to come and talk. And I think we're really lucky to have you share your knowledge and your. I mean, I'm interested in this idea of construction innovation, and it seems to me that you're both an innovator and an entrepreneur, which I think is really an interesting mix. So thank you for joining us. Thanks for the engineering club for supporting your talk and joining us tonight. And you're very welcome. And so thank you, Nan. Take it away.
Yeah, thank you very much. It was challenging, but yeah, we are managing now. And thank you for the invitation, and really happy to talk about Cleancrete, or as we call it, cement-free concrete. So now I have to manage to share the screen. Let me know if you see it. Can you see the screen?
Yes, thank you.
Yes? Okay.
Yeah.
So, as mentioned, I'm Gnanli Landrou, and thank you, I would say again, for the kind introduction. I will jump really quick into it. So, like, the challenge or the reason behind Oxara is the material choice that we use for construction. And today it's quite predominant that the go-to material is concrete. And now, and more so recently, the wood or the use of wood become, or like is brought to the mainstream architecture as a substitution. But if we look at the amount of material used and here is the case of Switzerland, and it's translated also worldwide, is that the wood availability won't be enough in order to respond to the global resource need to build houses or to build infrastructure. So in terms of resource, we need to find other means of construction that is not only wood, if we want to reduce the environmental impact of concrete. So the goal then is a low CO2 material is then needed. And this mainly comes from the fact that when we are building with concrete, we use quite primarily natural resources that are getting more and more scarce. And also the construction or concrete has a high CO2 emission due to the production of cement. And we are talking about 8% of global CO2 emission come from the cement industry, right? And during this phase of construction, either a building or during this phase of bringing a concrete to the site, we saw, or through different evaluation, we saw that actually there's quite a huge amount of construction waste that goes to landfill. And this is quite common. Either you are building houses where you need to make foundation, or you are building bridges or tunnels and so on, where you can dig within a mountain, and then you take out the excavation or the waste. And this excavation on a Swiss level, and this translates also in Europe, is around the same amount. So the amount of concrete that we produce for the building and infrastructure, coincidentally or funny, it's around the same amount of excavation that goes to landfill. And this landfill material is currently neglected, not used. And these materials, in terms of physics, look more like a concrete And this is basically where we see a benefit for excavation material. So, but there is quite a huge discourse when talking about excavation material compared to concrete. On a European level, it's one of the most available resources, and in Switzerland, it's the most available resources. And Europe, in terms of landfill, what is reported, we are talking about 600 million tons of excavation material landfill each year. In Switzerland, 47 million tons. In Paris, they have a project called the Grand Paris, where specifically in the city of Paris, they will excavate 45 million tons of earth that currently they don't know what to deal with it. And the discourse mainly comes from the fact that there is a huge skepticism on the material. So it's seen as a material for the poor. It's not a material that you can use for fast construction or that could cope with the social demographic or urbanization growth. And therefore, with the labor time that can increase your construction process by 4 times and the performance that is lower, then you have high issue on the cost aspect, and it's not seen as a material for the capitalist, right? And there is little regulation and policy around this material. So that's where I think that a lot of architects now have start looking at it as a material to like replace in some cases concrete as a substitution for non-high-rise construction. And there is a lot of work that is done with the Martin House, with the mechanization of the earth material. And we see the things even more on a holistic approach, where we try to promote building with clay based on technical performance, but also on the aesthetic of the material, with environmental and social issue at the core. And to be able to tackle that, we see 2 different ways. Either we go through the policies, or we go through the different stakeholder of the construction, meaning architect, engineer, real estate. So the whole architecture field need to lead the transformation if we are trying to reduce CO2 emission or divest slowly from the use or massive use of concrete. And that's kind of the approach that Oxara took, in a sense that how can we, from the bottom up, bring the technology by addressing the need from the architect and the engineer, while at the same time working with policymakers in order to put in place normative in Switzerland, but also in Europe. And Oxara here, it's a small interdisciplinary team, and we are currently 12 people. As mentioned earlier, I did my PhD at ETH, and most of the team members are part of the ETH curriculum, but we have also different people from the architecture, from the chemistry, the material science. And here's a little bit how our team is structured. So as Oxara, we work as an admixture developer. So we are here and we work also in a sense of analyzing Earth's material that we can suggest for either construction company or architect to use. Then from there, we develop the material that is used for a specific application. And when there is a project, we try to be involved there to see how we can support the construction company or the architect in better use of our product in the specific project. And to be able to reach that, we need to have our internal research, our material collaboration with large-scale material producer, as we try to be to provide the technology to the mass public. But we also work with construction company and engineering office and bureau, and that's where we believe that Oxara, which means community, have a value. So what is Oxara doing? And that's quite important. Oxara developed admixture, meaning that a powder that could help you transform the excavation material into building product. And the journey started in 2018 after I finished my PhD. So the journey started in 2014, finished my PhD in 2018, and then really quickly we tried to bring the technology to the market by having different partners. So a construction company as a partner, in the case focus here in Switzerland, Marti is the name, and also a material producer. In that case, it's a Kibak who produce concrete. And with them, we did a first pavilion that I will talk about. And in 2021, we had a Cleancrete floor, which is a cement-free concrete floor. That is another project that I will be talking about. And in 2022, where we materialized our admixture after a few validation, where we could also produce not only cement-free concrete, but also cement-free stabilized earth block. And through that time, we have finalized a project in Portugal, and we have few projects now happening in Zanzibar, in Goa, and in Switzerland. Right. So the ecosystem for us is how do we bring knowledge and technology from Togo to Europe, then from Switzerland to Africa to India and to the world. And this ecosystem needs to interact with all the actors of the industry and to be able to work together in order to either redefine the way we build. So here is a short video about port earth. And as you can see, it's the earth material with our local additive. And with this additive, we are able to use similar infrastructure as a normal concrete. So you take the earth, you add water, you put the additive together, and you have a material that has a consistency of a concrete, but is not aggressive to the hand. This is one benefit. The second is we are able to process it the same way as a normal concrete and put it in the formwork and then mold it after 24 hours. And this is depending on the type of waste that you have available. And after 24 hours, you can have a material that's self-supporting or self-standing to be used as non-structural element or 2-3-story high-rise construction, right? So this is basically at the end of the PhD what we are able to demonstrate, that our additive can help us transform excavation material or clay-based material into concrete. Now, if we try to compare the product that I have shown you, the cement-free concrete, with a normal concrete, that's where it starts being tricky. If we are talking about high-rise structure, we will fail to build it because of the performance of the product. So meaning that if we are talking about 10-story high, which will correspond to 3,000 tons, we would need to have an earth wall of 2 meters, which is a little bit crazy to do. Therefore, the use of concrete makes sense in that case. But if you are talking about a 3-story or 4-story house, which correspond to 300 tons, then if we talk in terms of performance, you can make with earth 20 centimeter thick wall, but with concrete, you need to make 2 centimeter thick wall. So the use of our load-bearing port earth or Cleancrete make more sense in this case. And that's where for us it's quite important to identify the right project and also the right application for our product at current stage. And how is the strength? So we know the strength development from normal concrete, where you have hydraulic reaction or chemical reaction. But in our case, we could see that we have, during the first hours or the first days, we have a small increase of strength, but then most of the strength will come through the drying. And the admixture that we have is providing enough strength so that we can demold the formwork. And then in terms of properties or environmental impact, If we compare it with concrete, we are talking about a low-performing concrete, but a low-performing concrete with CO2 reduction, with some quality in terms of hygroscopic and in terms of indoor air quality. But this low-performance concrete still have a use case, as I have shown you before. And when designing with it, one needs to think about the shrinkage and the water resistance of the material. So altogether, we need to change the mindset. We are not saying that with our product we can replace all the concrete, but identify the best use case. And the material choice become critical. And this goes through communication with the architect, the engineer, what is the right way to use our product. And here is the system, a hybrid system that we imagine and as a use case, where you have wood structure, concrete for the footing to prevent from the water erosion, earth as a filling element, and can play a role as a non-structural and structural element. So here I want to go more in detail on the different projects that I have mentioned in the previously. So the first project is an experimental project called the Geneva Pavilion, and here we work together with a multi-construction company in Geneva, in Switzerland, and the focus was mainly on wall system and how can we mix different type of soil from the region and combine them together. And we started in 2020, and in 2022 we are working on prefabricated element and poured floor. And what we have learned so far is, in terms of opening, if we are making arches, we have good quality of arches, we can make a full earth wall and come back and cut through it, and the material that is cut could, like the opening then is created, which could be like a windows and door. And the other type of way of making the lintel is with fire brick lintel. And how can we combine one poured earth with another one? We will recommend the use of butterfly anchors compared to round anchors. And this, we have tried it, and here's what we show, that if we use open or round anchors, we have kind of shrinkage and crack appearing there. And if we have wood lintel, we have also crack appearing on top of the picture, as you could see. And another challenge, if we are working with our material, is the temperature at which we are casting. We cannot cast at the moment below 10 degrees. So we need to operate at temperature above 10 degrees. The second project is a floor project, again with poured earth concrete. And here's kind of the picture of the church, which is on a land that is kind of inclined. So in this case, also it's quite tricky to have completely leveled floor. Therefore, we decided to cast directly on the soil of the church. And we were approached by architect Gianluca Pedreni, and we collaborate with the local construction company who knows about also rammed earth construction. And again, we use our partnership with the material producer Kiba to be able to supply the Cleancrete, the cement-free concrete. And here is like the making of the floor. So it was pumped over a distance of 70 meters. And here you can see the concrete truck who pumped the Cleancrete to the site. And what is really important is, because it's clay-based, you will have some cracks, and after 2 days, and if you come back after 2 days, you can fill it with a thin grout that we can propose to you, and then you can use it, and at the end, you have a finished surface that will not crack anymore. So there is a 2 phases. The first phase is to put the first layer of Cleancrete, then you come back to filling the crack. Here in this case, we have wait 3 to 4 weeks because we wanted to understand for the first test what is happening, and then afterward we filled it again with 2 to 3 weeks later. The third project was also an experimental project that started during COVID, and during that period, as we couldn't travel, a lot of work were done online, even the design. So the architect who owned the house, Tobias Ries, wanted to use our product. However, he was not sure how to work with it. So we used our internal architect to help him design a wood Cleancrete structure. That is, here you have the finish, and here is like this, the detail of the house. So we create kind of, instead of a steel reinforcement, a wood reinforcement in which we have cast our Cleancrete. And what is quite interesting is that the combination between the wood and the Cleancrete seems to match better. And this is not surprising, considering that even in the past, people have been combining earth with wood. And at the end, there is a plaster that is being made at the surface to kind of improve the finishing of the material. And this is kind of what you see here as picture. Right. Then, really quick, we start gaining some attention from the architect, from the engineer, who were interested to use our product for real, like large-scale construction. And the first one is the Burgville, and it's planned for 2024. And the architect here is a duplex, and the structural engineer is Valga Marini. In this case, the architect and designer and the engineer have proposed a building material and also wanted to use earth, but without knowing all the constraints of the material. Therefore, the facade were not protected and so on. So when we start discussing with them and trying to inform them about the material properties and performance and the do's and not do's, we start looking at how can we use it first in the first house, and then see on the long term how can we implement it on the other phase of the house. And the architect was not the only one who wanted to use our product, was also the engineering office, but also the owners. And this is kind of an intergenerational house that is they try to build with So here is kind of the materialization of the house. So some elements of our product will be used as external element, and some will be used as an interior. As exterior element, now we have been working, trying to improve the water stability so that it doesn't degrade, so that we prevent from erosion. While from the interior, we could accept that the material is not water stable, but we try to keep as much possible the benefit of clay in terms of hygroscopy. And when we were approached, the first question was for us is, who is the construction company that can build with our product? Because no one in Switzerland have been able to build with the product before. And we need to train this construction company in the building process, but also discuss with them on the drying and the construction time, right? The second aspect is we need to inform the engineer, the architect, the material producer, and also the construction company, but also the owner about earth and the low strength, the high shrinkage, how to handle it with earthquake, the erosion, but also evaluation of what is best application of earth in the building. And those different approaches led to preliminary tests where we evaluate the performance of the material, conducting since for a year different testing in trying to see how do we move from a cube scale, which is similar to a concrete testing, to a wall scale. And then we have done several mock-ups to evaluate the texture of the product, what kind of texture to prevent from erosion, but also if we want to create an aesthetic appearance. And we were looking a lot also about what is done from the rammed earth industry, mainly through Martin Rau, and try to see if we can do something similar or not with our product. We also investigate the precast system because the construction will be done in winter, and as mentioned earlier, we cannot build below 10 degrees. So, and we went on to do large-scale testing on a wall structure and trying to evaluate if really the performance that we have on a small scale, on a cube, translate also on a wall scale in order to identify the safety factor and the minimum wall size that we need to have. And more recently, we have built this mock-up that is currently standing on the site to evaluate the durability, the long-term behavior, and we have put in sensors to see how the material will behave over a period of a winter time, as the construction will start in 2024. So we have 1 year time to get to know even more the product. The second project is net positive living, and those are again another architectural project taking place in Goa. And the architect and client came to us with a specific vision. Our purpose is to advance sustainable design solution to create a world where people can live in regenerative community. And we design and develop products, service, and real estate center on net positive living principle, developed through joint R&D, innovation, and offer across a network of partner and location. And here's the construction. And in this specific case, what is really interesting is how do we bring our Swiss knowledge, which is quite technical, to the local. And it goes through a lot of interaction with the local craftsmen and what we call tacit knowledge, and to be able to advance the implementation of or the use of our material in India. And there's also huge interest from their side to be also circular, so reuse of other piece of, for instance, the door as we see here, or block or waste stone that we can see on this picture. And we began also doing preliminary tests in trying to see how our admixture will behave with the local soil. And through that, we saw also with different tests on this specific block that with our admixture, and if you see the graph on top, we are able to make material that have 10 megapascal and have better moisture coefficient or absorption coefficient, but also have lower abrasion or erosion capacity. And what we admire also with them is that they want to grow together with the people they work with. And this project is supposed to start in February 2021. Therefore, it's not yet built. And but in February next year, sorry, not 2021, February next year, we will see the first piece of wall being erected. And the last project where we are working on is what we call the Pavilion Zero. And for us, the Pavilion Zero is a way to demonstrate how can our product be used in an industrial way in Europe. And we approached the city of Zurich, where we are based, and also the Ministry of Environment, to give us a possibility to demonstrate that our product can be used not only as a niche product, but can be industrialized and being produced. In that format, we got the support from the city and the Ministry of Environment, but also research institute. So here we are talking about University of Applied Science in Lucerne, who gave us 200 square meters of plot land. And our goal is to show that with Cleancrete, we can create a landmark for sustainable construction. And for that, we need to collaborate with all the different actors. So the material like producer, Oxara, the construction company, the engineer, but also the university, in order to design and come together on a product or a building that makes sense for all. Right? And the goal of the Pavilion Zero is split on the research side, where we try to get as much information for a possible certification or normative. On the market side, where we try to raise awareness on the use of the product at an industrial scale, but also with well-known engineer and partners, construction partners, and on the industry scale, where we are able to industrialize most of the process and get information on the price, the cost, the LCA, and have readiness of all the industrial partners. So the project is divided in two phases. The phase one is what we can do before summer 2023, and it's a small exhibition center that we try to create, and currently under design. And the second phase is for summer 2024, where we will work together with students to create workshop and design the workshop by the meeting space and the storage space. And our goal there is to test different building elements based on cement-free concrete technologies. So it has block prefabricated on-site fabrication, use of like waste material or not, load-bearing or not load-bearing hybrid system or not. And our three main focuses mainly around how can we achieve zero in terms of net zero or in terms of circularity. The second is the form, what kind of form and shape can we use our material for? And the third one is the comfort, can our earth-based product provide good comfort material? And most of this strategy toward zero emission, in our case, is focused on CO2 emission, or at least in Switzerland, on the operational level. But what we try to show is that on the operational level, there's already a lot of work that's being done. And with Pavilion Zero, we want to show the work on the embodied energy, therefore the use of a more sustainable building material. And so the main idea would be, how can we break down the complexity of Port Earth to all the actors and showcase what is possible, and also define application guidelines. And and we want also to demonstrate that the material have an effect on the design, which will have an effect backward on the material development, but also on the engineering aspect. So here's kind of the zero design structure mentioned already, that it's a work together with university, with research institute, but also implementation construction partners. And on the final note, I want to say that for Oxara, which means community, our goal is on one side to have an embodied energy like close to zero, and for that we need to scale the use of like products or technologies that exist now, and this is possible through architecture. Architecture as a leading the transformation. And the second, because there is a variability on the earth, let's say in the UK, we might need to set up a new type of network in order to be able to work efficiently there, and also analyze the local soil. And what we try to promote through all our projects is not that we want to revolutionize the industry, but redefine how we can work together with a local material that adapts to the local context. And architecture, again, is a leading force for this transformation. So, thank you very much.
Thank you so much, Gnanli. Should we take do you want to take the online questions first? There's a question here from Peter. Can you see that? Would you want me to read that out? If you press the purple thing on the side panel.
Yes. So so I'm interested in scalability and wonder what sort of response you have had from lender and from building control. Yes. So, like, this is quite important question, and I won't say that it's challenging. It's quite challenging because it's a new product. It's not concrete. It's not wood. It's not fired brick. So they are quite reluctant, and that's why we try to have the journey with them. We try to share with them with information how what is earth construction, give them references so that they could relate to or even make a workshop bringing them to new earth construction site or to visit earthen house. And once we have passed this kind of stage, then they are more familiar, and we on our side, we try as much possible to have data and science ready to be able to answer some of their questions. Of course, not all of it is available now, but we try to make the right test to be able to answer the question. And the ecosystem that we have around, from well-known architects, engineers, research institute, is helping us a lot to be able to validate the use of the product in a building. And we hope that at the end, we will be able to generate a building code specifically with a poured earth or cement-free building product. Then, can you speak a bit more about the white powder? Yes. So the white powder is the additive that we have developed. So it's mainly a lot of mineral salt, and this mineral salt come from different industries. So, and can be used also in a food industry. Is used also. Some part is used in the construction. Some part are also some waste from agricultural industry. And what is quite important is that they are not toxic and non-hazardous. And it's a mix of, let's say, sodium chloride, magnesium oxide, aluminum, and quartz. So different mix of this mineral that we try to put together, and then to have it stable enough to, that when we add it to clay, they are able to react. What service does Oxara provide in the design process? Do you specifically help to develop the poured earth mix or something more? So, so in our team, we have architects that have been building a lot with earth, like poured earth or not poured earth, rammed earth, adobe, and we try to learn as much from them in terms of what is the right practice for earth material. Then the second, so this is when we talk to an architect or a design office, we try to help them understand what is earth construction. Second is that in-house we do a lot of application tests. So how can you make a floor? What is the insulation you will need to have? What is the layer thickness that you will need to have for the screed, for instance? Can you cast on the wood or on the concrete? What is your interface look like? Or do you need a dilatation joint? So we do most of these tests. And also on the wall, can you make 20 centimeter wall, 25, 30? How is the interface between wood and Cleancrete? Do you have dowels or not? What type of dowel? Or with concrete also? So we try to give them concrete answers to their specific question. And through that, they are able to then direct their design methodology. In addition to that, of course, we do the formulation of the mixes for the Cleancrete. Do you have any idea if the material property composite, for example, can be improved? Yes, now we have developed a new, so in the category of cement-free concrete, or called Cleancrete, which is not present here, we are now able to produce a Cleancrete called Cleancrete Ules that have 25 megapascal. And this is a product that we have been working on for a while now, and we hope to see it soon tested and used in construction. So we have the 2 to 4 megapascal material, that is the initial product, but we also could produce 25 megapascal product. So are you working on studies to see if different base soil or improvement? Yeah, so again, here it's an improvement not only on the admixture and on the soil, but it's both combined. And we try also to look at building technologies as well. So can you make porous formwork? Can you add porous aggregate and so on? Is your secret formula copyright free so that the poor can use it? So in general, like, we have a patent on it in Europe, and when we do projects in Africa, oftentimes we share it, but at the same time they would need to have a certain purity of the product so that it works efficiently. So at the end, it ends that they try to get it from us. So yeah. So does the Cleancrete have a better thermal efficiency than standard wall system or other soundproof? Yes, the thermal, either the U value is much lower than a concrete wall, and I don't remember anymore the numbers. I can share it with you after. And for the soundproofing, it's for the acoustic, we are oscillating within similar performance as a normal concrete. So 2,000 kilogram per cubic meter. So we believe that in terms of sound system will also be the same. Yeah, I think it will be also interesting. Pakistan, as last week I was in India trying to build with the case design on the project in Goa, but also a peace pavilion in Apsara, which is a school for young girls. And yeah, we believe that it's the need of our product is mainly there, and that's where the vision of Oxara come in. It's like sustainable construction, but also affordable housing. So how can we use back our technology to places where it's needed? So in terms of CO2 on the admixture, which is called Oxacrete for cement-free concrete. The Oxacrete have, if cement has 0.8, the Oxacrete has around 0.2 kilogram of CO2 per kilogram, and the cement have 0.8 kilogram of CO2 per kilogram. So it's for 80% reduction. And in terms of quantity, we add also quite less. If using, does the admixture have to be imported or can it be produced locally? Okay. So right now we are not in UK as a company, so we need to produce from Switzerland. but our goal is to expand also to UK, and there is like production possibilities in UK that we are now discussing. And also our project in India, we have to produce it locally. The project in, we have another project in Zanzibar, in Tanzania. Most of our project, we try to produce our admixture quite locally. So in terms of waterproof, so the waterproofing will depend on the type of admixture that we will use. And as I have shown you for the block, we could see increase of water, like we improve the water solubility, or we decrease the water solubility, so the material is more waterproof. But then we are able, like we reduce also the hygroscopic behavior. So there's always a balance that we try to set together. Is the thermal capacity similar to Earth or Cleancrete? So we are close to Earth or around Earth in terms of thermal capacity. I will try to find the number and then share it with you. Any application for below ground basement construction? So right now it's not a material that we will recommend for structures, or we can use it for filling, but not too much as like structure below ground. If it's just to fill around trenches and filling space or cavities and so on, this is fine. But it depends what it's called here, below ground construction. Yes. So are the hygroscopic characteristics similar to unbaked? Yes. What are the requirements for earth? For the earth you use, does it need to have a well-controlled proportion of shrinkable soil? How do you source it? So there is a lot of work there in terms of understanding the quality of the earth. That's why we have in our team group or institute or like a small group working on specifically understanding the earth in that we collect so far. And we have been testing different type of earth. Indeed, we need to have a controlled proportion of clay, aggregate, sand, silt, but this is really depending on the earth that is available. So what is required to prepare stabilized earth block? So the stabilized earth block, which is in our case cement-free, it's normally you have a compressed earth block, and instead of adding cement, you add our admixture to the earth, and then you have a material that could be used as a normal stabilized earth block.
Hi, Gnanli. Can we take some questions from the room now?
Sure.
I'm sorry, getting bombarded with questions.
Yeah.
Yeah.
Meantime, I try to find the data for the thermal behavior. So.
Okay. Well, thank you.
Yeah.
Any questions?
There's a mic here. You can just raise your hand and I'll pass the mic.
Thank you for the lovely lecture. I just wanted to go back to the cracks. I was very curious to know what is the filling mixture to fill up the cracks. Thank you.
Mm-hmm. So the crack mainly comes from the shrinkage of the earth. So because when you add water to the clay tends to absorb more water than he needs. So at some point, the water needs to go out. So when going out, you will have the crack. So what we do after is to refill the crack with clay with our admixture again. And because it's filling only the small holes, like fissuration, then you don't have so much crack visible anymore. And once you have done it once, or in some case, if it's huge crack twice, then you have a finished product. And the floor that we have made in the church, after 2 days, the worker start working on it. And like for us, it was like, why would you do that? But it's tend, and we are quite happy to see that they use it as a normal product. Yes. Have you tried fiber reinforced Cleancrete? If so, what fiber do you think Cleancrete would work in? Cleancrete field, steel, tube, or grip?
So Gnanli, there was another question in the room. I don't know whether you could hear that. No, shall I try?
Ah, no, I couldn't hear it. I couldn't hear it. Sorry.
It's flashing. Is it on? Okay.
Yes.
Hi, thanks very much for the talk. I was wondering if you knew that in the UK we have an exhibition, construction exhibition, which is now, it used to be called EcoBuild, it's now called Future Build, and it takes place in London usually in March. We haven't had it for the last 2 years because of the pandemic, but I assume that it might turn up again next year. Your product and your system seems to be an ideal thing to present there, and possibly even have some kind of show or presentation where you can actually demonstrate the material to people and make them feel more confident about it. But I would suggest that if you contact the Future Build organizers, they might help you and subsidize you to come over and bring some samples over and put them on display there. And they have a big program of presentations and talks as well. So I'm sure that they would want you to do one of those at least.
Yeah, like I will be quite happy to learn more about the event or the conference, if possible. To maybe like you can send me the email or the link.
Yeah, I'll talk to one of the organizers here and arrange to get that information to you. Okay, thank you.
Please, thank you very much.
May I? Hi, Gnanli. Again, what a lovely talk. Thank you very, very much. I'd also like to put in a plea for the more disadvantaged parts of the world in particular, who you mentioned in your development that capitalism was one of the problems about the uptake, but you take a very capitalist approach to the patent and the distribution of the material. So could you see a sort of geopolitical solution where you treat the developed world like Europe in one way, and maybe the less developed world in a different way, and just give them the product and say, get on with it? Because it's a very important issue to reduce the amount of carbon and to give homes to people. I can't think of anything more important really in our world at the moment.
Yes. No, and I completely agree with you. It's at the end of my PhD, the goal was to like leave directly to Togo or like Africa and do some NGO work. And I realized really quick that I would need some money to be able to reach that. So the way we structure Oxara, there is a business part, but also there is a social entrepreneurship part, or like social aspect, meaning that we have a project in Mexico, which I haven't talked about, and also a project in Togo called Open Eye Clinic that is done by our team on 20% of their time. So the way we structure our team is that we work 80% of business and we try to work 20% as free time where we can focus on like social projects. So that's one way of us to contribute. And the second aspect is how can we like get the revenue from the business side to infuse in the social aspect. And that's what we set up with the Oxara social development. So we try to have a certain amount of the profit generated or revenue generated from the business to put it in the social aspect. But I also clearly agree that we need to bring the material to the people and have a training program where the local learn how to use it, and through our technical knowledge here support them or answer some of their questions so that they are able to implement it by their own. And I agree with that. Now it's how can we do it efficiently so that the large corporates don't take advantage of it as well. But if you would like, we can, if you have great idea also there, I would be really happy to hear the input. So we can have a discussion later if you want to.
Thank you.
Thanks.
Any more questions? Yeah.
Just want to thank you for giving us the opportunity to, know more about this amazing concept that you've developed. I would like to know more about the process. Is it really capital intensive regarding producing this amazing, sustainable alternative to the traditional cement? I just want to know, is it really capital intensive? Thank you.
So, thank you. I think this is also a really good question in terms of pricing that we are now more and more getting to the core of it. So we did a first evaluation of the cost, and we use in a normal Cleancrete around 10 kilos of our admixture, and the rest is mainly excavation, right? So, and the estimate show that we will be around the cost of a normal cement, 200 or 250 kilos. So which mean that at the end we have a product that will cost almost the same as a normal concrete. What we are now improving is if you have this crack and then you need to come back and fill it, then it creates additional cost. And it's more on how to best use it to on a building site to avoid this extra cost instead of the material cost. So it's more the application cost that we now try to work together with a construction company in order to bring it down to regular concrete cost. But so far it's a discussion we are having, trying to see how can we optimize and improve. But in terms of material cost, we believe that if well scaled, we could have a product that could be up to 20% cheaper.
Thank you very much. I know there's a couple more additional questions from Derek Taylor, but I just wanted to say thanks again, but also just to reinforce this idea that you've made, what you've made with the admixture is you allow the material to be, you can use the infrastructure of the concrete industry. Is that right? I mean, you could use the cement mixers and all of that stuff to get things to site, to pour things, to pump it, and that's a massive change, isn't it? Because in terms of earth construction before this, it wasn't. It was about it's much more labor intensive and in a different way. You know, I'm not criticizing that, but I think that's super interesting, and I don't know whether that comes across enough. I just think that is kind of is the really interesting thing about it. One of the interesting things about the material. But just to go back to the Derek question. I mean, I was going to ask the same thing about the reinforced. You know, can you reinforce it with fibers? And if you were going to reinforce it, what? I mean, I'm guessing if it's got salt in it, you know, you don't want to put steel in it. You don't want to put steel in it anyway, probably.
Yes. Yeah. So in terms of reinforcement, I will not put steel, and I can show you really quick I was showing few of the information presentation I did earlier this month. So can you see here the water vapor resistance of the U value or the mu value?
No, we can see thermal conductivity. Oh, water, yeah, maybe just click on, oh, yeah,
Yeah.
yes.
Yeah. So here's kind of the water vapor resistant. So we could see that we're a little bit higher, but quite low compared to concrete. And the other hygroscopic potential is the product in terms of moisture buffering value, which is also good compared to either stabilized rammed earth or concrete or fire brick. And those are important characteristics when we talk about the quality of the earth or the Cleancrete product, right? And another aspect, yeah, the waterproofing or erosion. So at the end, if you leave the material in water, at some point start to dissolve again. Therefore, we need to protect it from rain or from for using before using for facade. And this is the question about reinforcement. So the project in Portugal, we have used typical wood as a reinforcement, but there is also possibility to use bamboo or as kind of a reinforcement as well. So instead of steel, you can have a bamboo mesh and then pour the earth inside, and then the bamboo will act as a reinforcement of the Cleancrete. And of course, we add fibers. We can use straw fiber, flax fiber, hemp fibers, and all these we have tested, and we have some have quite great value, some not, but it's still a lot of work ongoing in terms of the best mixture, the best quality, yeah. And it's also a lot depending on the earth that is being used.
Great. Well, thank you so much, and thanks. And again, so nice to have so many questions. But
yeah.
And look, I hope we see you in person next time.
Yes.
And,
no, but, yeah.
So yeah, I'll sort out the visa sooner rather than later next time. But thank you so much for joining us. Really appreciate it.
No, thank you very much. And yeah.
No, yes, to log off now, you go to the top, your top, that side. Go to the top left-hand side.
Yeah.
And then you go leave session.
Top left.